So with our highlighter, when the numerator and denominator of a fraction are polynomials, we call that a rational expression. So here are some examples of rational expressions. These ones are not rational expressions. Here we have 2 to the x. That is not a polynomial. Here we have a square root of x. That is not part of a polynomial. A polynomial is having an x to an exponent that is like x squared, x cubed, x to the 4, and having numbers in front. So if we look back at the examples that were rational expressions, okay, a polynomial is when you have variables, your exponents are all whole numbers. You have no square roots, no fractional exponents. Okay? And in one of the things that we've talked about already, we can't have things that make the denominator 0. And these are called non-permissible values. So if you had x plus 5 over x minus 3, you can't have x equals 3 because that would make you divide by 0. So we call 3 a non-permissible value. Example 1. Determine the non-permissible values for each rational expression. In order to do this, we're going to need to factor the denominator, because this is going to be connected to our solving quadratics unit. So in A, when I look at this expression, can I factor the bottom, x squared minus 9? Yes. It becomes x plus 3, x minus 3. And then once it's factored, it's going to be easy for us to tell what the non-permissible values are. So we'll NPVs, non-permissible values. What would make the bottom equal to 0? Well, we can look in each factor. If I look at the first factor, x plus 3, what would make this 0? Minus 3. So we would say, as a non-permissible value, x can't equal minus 3. If we look at the second factor, x minus 3, what would make that equal to 0? So x also can't equal 3. And this question has 2 non-permissible values. So can you see how when we solved quadratic equations, we made one side equal to 0 and we factored it? And this is the same idea, except now we don't want the bottom to equal 0, but we still use the same idea of factoring and finding what would make it equal to 0 to determine the non-permissible values. In part B, we have 3x plus 2 in our numerator, x squared minus 18x plus 16, x squared minus 8x. What works? It's going to have to be x and x. 2 numbers that multiply to give you 16. Minus 4 and another minus 4. Our non-permissible values? X can't equal 4. And x can't equal 4 again in the second one. But there's only one value then that's a problem. X can't equal 4. Okay, questions for practice. Numbers 4, 5, and 8.